Today we're going to look at section 9.1, which is right triangle trigonometry. And the first part of this section is actually a review of material that you learned when you were in geometry. For this section, you need to know the Pythagorean theorem. That a squared plus b squared is equal to c squared in a right triangle. If this is angle A, this angle here is B, and this angle here is C. The side across from angle A is side A, the side that's across from angle B is side B, and the side that's across from angle C is side C. Notice that for angles, we're using capital letters, and for the sides, we're using lowercase letters. Okay. So the two legs squared added together is equal to the square of the hypotenuse in a right triangle. Remember that only works for a right triangle. The other big idea that you need to remember from your geometry days is SOHCAHTOA. So if we have a right triangle, on my right angle there, and I'll call this angle right here angle theta. It's a Greek letter that's often used to represent angles. From this angle, the side across from it here, this is my opposite side. The side next to it is the adjacent side. And the side that's across from the right angle is the hypotenuse. Okay. And with that setup, we know that the sine of the angle is equal to the opposite side over the hypotenuse. If you want to write out the whole word's opposite and whole word hypotenuse, you can. I'm just abbreviating. If you want to abbreviate just using the O and the H for opposite and H for hypotenuse, feel free. But what this says is sine equals opposite over hypotenuse. Cosine of the angle is AH. So A is the adjacent side over the hypotenuse. And TOA, tangent, is equal to the opposite side over the adjacent side. The other thing that's going to come up in the geometry review portion of our notes today is that when we're discussing an angle of elevation or an angle of depression, this is the angle that is made with the horizontal side of the triangle. And just like in class, sometimes I need to click that document camera one space out so you can actually see the whole paper. So if I have a right triangle like this, that angle there would be the angle of elevation. You're standing down here and looking up. That angle you're looking up gives you your angle of elevation. If you're up here and looking down, this angle between Here and here between the hypotenuse and the horizontal side is the angle of depression. So if you have a word problem that talks about an angle of elevation or an angle of depression, just make sure that when you set up your triangle, you label that angle as the one next to the horizontal side of your triangle. Let's take a look at a few examples. In example 1, we have a parasailer that is attached to a boat with an 80-foot rope. The angle of depression from the parasailer to the boat is 59 degrees. And we're going to use that information to estimate the height of the parasailer above the boat. And the first thing I'm going to do in any word problem is to draw and label a diagram. Now that diagram could just be the right triangle, or you can pull out your artistic skills here. So here's my super fancy boat. It's great, isn't it? And it's sitting on the water, of course, so we'll add a few waves here. And here's our rope up to our parasailer. You could even put a little stick figure parasailer if you wanted. And then I'm going to draw in my right triangle. Okay, we know the rope is 80 feet. So from the boat to our parasailer is 80 feet. And we know the angle of depression from the parasailer to the boat is 59 degrees. Remember that that angle of depression is always the angle that's made with the horizontal side. So from the perspective of the parasailer, you could draw in an extra horizontal side. All right, this angle here is 59 degrees, but that's also going to be the same as this angle here. And our goal is to figure out the height of the parasailer above the boat. So this height right here. So from my angle, this is my opposite side. This 80-foot side is the hypotenuse. And this would be our adjacent side. So looking at the information that we have here, the two sides that we are trying to work with are our opposite side and our hypotenuse. So opposite and hypotenuse tells me that I need to use sine. And sine we know is equal to the opposite side over the hypotenuse. So now if I substitute in the information that I know, the sine of our angle, 59 degrees, is equal to our opposite side, which is x, over our hypotenuse, 80. And if we're going to solve that equation, we would need to multiply both sides by 80. If it helps you, you can show that step. So now we have 80 times the cosine of 59 degrees is equal to x. Now, you would have to have a calculator for this, and you'd want to make sure that your calculator is in degree mode. So when you type in 80 times the cosine of 59 into your calculator, you can round to the nearest tenth on these problems. I get about 68.6, and since this is a word problem, make sure you're labeling your answer with units, so we're measuring this in feet. All right, let's try another word problem. Example 2. Palouse Falls in eastern Washington is 200 feet tall, according to Wikipedia. According to other sources, it's maybe a little bit different, but we'll go with this one because it's a nice friendly number. You are standing 50 feet from the base of the waterfall. What is the angle of elevation from your location to the top of the waterfall? And I apologize, I should go back and add in one extra piece to example 1, that our second step was to set up and solve a trigonometric equation. All right, so same 2 steps. We're going to draw and label a diagram, and then we'll set up and solve an equation. So here we are. I have a beautiful stick figure. We have this waterfall. Okay, beautiful waterfall. And if we draw this in with a right triangle, and I'm seeing this that it's obviously not to scale, but that's okay. I'm going to go with it anyways. So we know our waterfall is 200 feet tall, and that we're 50 feet away from the base of the waterfall. And our goal is to figure out the angle of elevation. So the angle is made with the horizontal side, so this angle right here. If it helps you, you can label it with opposite, adjacent, and hypotenuse. So across from our angle, this is going to be the opposite side. The hypotenuse is across from the right angle, and the other side is our adjacent side. So the 2 sides that we're working with here are the opposite side and the adjacent side. Opposite and adjacent use tangent, TOA. So tangent of theta is equal to opposite over adjacent. So we can say the tangent of theta is equal to our opposite side, 200, over our adjacent side, which is 50. And now our goal is to find the angle, to find theta. So we have to undo tangent. And to undo a tangent, we're going to use inverse tangent. Which on a calculator would show up as the inverse tangent button, or oftentimes you'll have to have it second and then go up to that, but it's tangent with a little -1 on top of it. So if we take the inverse tangent of each side, inverse tangent undoes tangent. So on the left side, we're just left with theta. And on the right side, on your calculator, if you do the inverse tangent of 200 over 50, it works out to be a really nice, friendly number of 76 degrees. All right, continuing on. One more example that's review, and then we'll move on to the stuff that's new for Algebra 2. Turn my paper. In example 3, we're going to solve each triangle. And when the directions say to solve, they're really asking you to find all the missing sides and angles. And these problems might be given to you with a diagram already set up for you, or they might just give you a list of information and then you have to draw the triangle and label the pieces yourself. But either way, the process of solving is going to be the same. So in example 3A, angle A is 29 degrees, side A is 7, and in example 3B, we know that side A is 8 and side B is 10. And we're going to have to find all the other missing pieces. So in 3A, we're going to have to find angle B, we're going to have to find side B, and we're going to have to find side C. In example 3B, we're going to have to find side C as well as the missing angles A and B. Now in our first one here, we know that the angles in a triangle add up to 180 degrees. So if we subtract the two angles we know, this 29-degree angle and a right angle is 90, we can find angle B. So angle B equals 180 minus the 90-degree right angle minus angle A, which was 29, and that leaves us with 61 degrees. To find the missing sides, we're going to use SOHCAHTOA and or your Pythagorean theorem. In this case, I can't use the Pythagorean theorem yet because I only know one of the sides. I would need to know two of the sides in order to use the Pythagorean theorem. So we are going to have to use SOHCAHTOA. You can choose which side you want to find, whether it's side B or side C. Maybe I'll start with side C. So if I'm looking at side C here, I know angle A. I know the opposite side. Again, you could label them. So from angle A, this is our opposite side. Side B would be our adjacent side, and side C would be our hypotenuse. All right, so side A is our opposite side. If we want to find side C, that would be our hypotenuse. Opposite and hypotenuse tells me that I'm going to be using sine. Sine of theta equals the opposite side over the hypotenuse. So sine of 29 equals our opposite side 7 over our hypotenuse, which is C. I don't really like having C in the denominator, just so to fix that, we're going to multiply both sides of this equation by C. So now we have C times the sine of 29 is equal to 7. And to get C all the way by itself, we can divide by the sine of 29. And if you type that in your calculator, making sure that you're in degree mode, that's going to give you about 14.4 if you round to the nearest tenth. Now, to find side B, you could either set up another trig equation, and you could use cosine to find B over side C, since you know it now, or you could say the tangent is equal to 7 over B, totally up to you. Or, since we do know two of the sides, we can use the Pythagorean theorem. A squared plus B squared is equal to C squared. We know A is 7, so 7 squared plus B squared is equal to side C is 14.4 squared. 7 squared is 49. Plus B squared equals 14.4 squared happens to be 207.36. If you subtract 49 from both sides, you get B squared is equal to 158.36. And if you take the square root of both sides, B equals the square root of 158.36, which comes out to be about 12.6. And now we have found all of our missing sides and missing angles. All right. For example, 3B, we know two of the sides, so a good first step would be to find the other missing side with our Pythagorean theorem. All right, so our Pythagorean theorem, A squared plus B squared is equal to C squared. Side A is 8 squared plus side B is 10 squared is equal to C squared. 8 squared is 64. 10 squared is 100. 64 plus 100 is going to give us 164 equals C squared. And to undo squaring something, you would take the square root. So C equals the square root of 164, which is about 12.8. Now we know all the sides, we need to find an angle. So we're going to find one of our missing angles using SOHCAHTOA. You can choose what angle that you want to find. Maybe I want to start by finding angle B. From angle B, 10 would be my opposite side and 8 would be my adjacent side. We know tangent is equal to opposite over adjacent. So the tangent of angle B is equal to our opposite side from angle B, which is 10, over our adjacent side angle B is 8. Again, to undo tangent, you would have to do inverse tangent. So B is equal to the inverse tangent of 10 over 8. And if you type that into your calculator, you get 51.3 degrees. And then again, remembering that since the three angles need to add up to 180, to find angle A, you can do 180 minus the 90-degree angle for C, minus angle B is 51.3, and we get 38.7 degrees for angle A. And now we have solved that triangle.